So starting with Pythagoras, let's just go large. I'm not going to write anything, I don't think. There you go. So you're all very good at Pythagoras for sure. You've been good from year 8. Everyone loves Pythagoras. So that's a quick demo of how I relaunched it in year 9. Remember, this is going on video, so every little screenshot you see is more revision for you. It's definitely worth watching. That's me setting questions. There's also Pythagoras Plus from one of our previous lessons where we did more tricky questions. I think this looks a bit like ordinary Pythagoras. Yeah, you can either do it the long way like that, or being year 9 top set, you can do it in one step like that if you want to. That's me revisiting this question here, so that relates to that right there. That's proven that Pythagoras works in terms of geometry. If you set up 2 squares of a known area and make a right angle triangle, then right angle triangle, yeah, then the square automatically created on the long side will be the sum of the 2 sides added up, of the 2 areas added up. Do you see how I made a mistake there? Somebody came into the room and I lost my concentration. This was the Pythagoras Plus question where you had to discern whether a triangle was right angled. If this works out to be right angled, then 34 squared plus 15 squared will make 38 squared. But you need to prove it. Don't just say that plus that square plus that square equals that square. Actually work it out and show that you get the same answer both ways. That's what that was about. Again, it's there. Clearly I did it on the video because I pasted the pages on again after you've done that classwork. This is a Pythagoras Plus type thing. A triangle with a triangle, you can't get x directly. You first use the 31 and the 19 to get this length as seen there, and then use the 2 short sides to get the big side called x, and that's that bit right there. And again, I'm using high level 1 step, and this is on a previous video. If you want to revise that, you've still got the links on Show My Homework. If not, you've got this fresh revision now. This is a question I did for Neha. Again, some of you couldn't do this either, but Neha actually wanted it. So Neha, just this is for you and anyone else. I use the 21 and the 35 to get the short side A. I use the new A I've just created and the 16 to get the short side B. But of course, B is the long side of the last little triangle at the bottom. So to find x, finally, it'll be b squared, take away whatever, 18 squared, then you root it. So that will be grade 6, you know, because it's Pythagoras taken to a new level. And you're the first year group where I felt I could actually teach Pythagoras in 3D. I remember Hamza having a go at this verbally and offering his contribution, so thank you for that again, Hamza. But you were brilliant at this. This was the questions I downloaded from a good maths teacher, and you were really, really good at this. I actually enjoyed marking it because it was so well done. And then we come on to trigonometry. You will be aware that there are the 3 rules of trigonometry. Look, when you do your assessment, please don't cheat. You've got to learn these rules. And because I knew trigonometry is tricky because there's 3 rules to have to learn and also rearrange, because sometimes you're going to find the angle, sometimes you're going to find one of the sides that they want, and you've got to pick the right rule, and only one will work in any given situation. Cool? So that's why I split off those questions to 4 little lessons. I did trig 1, 2, 3 and 4, and you had little tasks to do at home, and because I knew it was tricky and I couldn't help you because I wasn't with you when you did it. So here's an example. I've got the opposite and the hype, so that's all about sine, so I can find the missing length b. No, what's the first thing? No, let's do the red stuff. I've got the h and the 8, so it's opposite and height, which is in fact sine, and I found the height of that, and then I invented a question b, so b over 8 would be the cosine of 34. I didn't want to waste a good diagram, so I got 2 questions out of 1 there. It's all there, and of course if you're watching this on YouTube later on or now, pretending like it's already up, then of course you pause it and study that, and of course you study and pause to your own work. Here's an example with working out tangent. Again, this is grade 5 and gets higher than that. This is the first example where the side that you want appears. Let's have a look. Yeah, this is a bit more involved. The x gets trapped underneath because it's the hypotenuse, so you've got to rearrange it carefully to get the right answer. You don't say x over 15 just because you want the x to be on top. Sine is opposite over hypotenuse, so it has to be 15 over x. You can't make the maths do what you want it to do. You have to do what it says. And there's more questions there. We're finding the missing angle. You may recall that once we have a cosine of something and you shift cos it, it will spit out the angle to 1dp, or we can write it in one step like that. Note that theta is a Greek letter that represents angle traditionally in mathematics going back many years. And if you've worked out the sine of the angle, just shift sine it and it will give you the angle. Casio can do that, provided you ask it in the correct way. What's that? That's me going over a question that you did in class, and that's me projecting more questions. We're using trig. How would you do that one, for example, to find that angle? Well, the op is 7, the ag is 2, so you have to go shift tan, 7 divided by 2, close bracket equals, it will give you that angle in one step. We can do that. So I think trig is sorted out. Oh no, we're finding the angles. I've clearly gone over that. I've reasoned with this one, for example. Which one's that? If it's A, then it's probably that one there. Yes, I've got ag over height is the cosine of angle, so you need to shift cos it. And then obviously I talked through that, which means it's on a video somewhere. So you can look at that, or look at your brilliant work that you did in class. Another example. Don't know why that's there. Don't know why that's there. It must be from other years where the students wanted help with it. Yeah, you may recognise that. That's straight from the book. That was really well done. A demo. Now congruent triangles, the 3 rules. Now I've worked harder for this class, even more than year 10, because I'm trying to get your attention remotely. 3 rules: side, 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 angle, side, angle, side, angle, side, and the one they didn't teach in year 9, right angle, hypotenuse, side. And so I scoured the nets to find slides like that, which we talked around. Slides like that, SSS examples. That's my rubbishy diagrams from years ago. And I thought I'd find some proper ones. It's all here, it's all on the video. Here it is again. Study this. And that's me doing a question with you. Yeah, it's just there, it's very clear. That's me teaching the 3rd rule, side angle side, SAS. And that's me downloading a slide from previously, and it's on a previous video. Please use that. That's me taking a slide out of the Maths Watch CD, which I'll buy a few next year. And the question was, are these congruent? The answer is absolutely not, because you may recall that the angle has to be between the 2 sides. The angle must be included, not excluded from the 2 sides. And I gave a little black dot there and there. And had it been there, in those positions, then those 2 triangles would be identical, hence congruence using the SAS rule, had it been positioned there. Okay, it's all grade 6 stuff, this. And the last one, RHS, and I scoured the net to find that one, and we talked about it, and we did some examples together on screen, and that's us having a chat, identifying the congruencies in each case, which identify them as identical. And the justification is that's all you have to say. You don't have to write down side, side, side. You just write SSS, and in the context of the question, examiners at GCSE know exactly what you're trying to communicate. Then what? That was a very high level GCSE proof question. I did a specific video on this. I did a specific video on that, as you can see, and you can find that online because I will have given it to all of you, especially to those who attempted the question. Congruency, that means, sorry, I've done congruency, I don't know why it's there. Oh, that's me launching from a previous video. Okay, so similarity. If you want to discern whether shapes are similar, you need to find if all the sides are in the same ratio. In this case, they are similar in this demo. So, for example, 9 divided by 6 gives me 1.5. So the scale factor enlargement is 1.5. So to find out missing length A, you just take the little 4, times it by 1.5, and you've got 6. Remember that angles in similar shapes are preserved. They don't change when you enlarge or reduce down the shape. Otherwise, they're no longer mathematically similar. And this is me doing a question probably from the book, showing you that even though you've got two rectangles, they're not necessarily similar. 15 divided by 3 is 3. It appears to have an enlargement scale factor 3. 5 divided by 2, unfortunately, is not 3, so doesn't work. So this is not as big as it should be had it been scale factor 3. If it was scale factor 3 for all sides, then that would be a 6. So we've proved that they're not similar. All right. And here you have to do a similar sort of thing yourself. Are they similar? Well, there's an example there. Green goes with green, yellow goes with yellow, and both divisions show that the enlargement scale factor is 2.5 in both cases, and the included angle is the same. So they're perfectly similar. That's what we've done. This one looks like it's similar. It's not. So I gave an example where 7 divided by 4 gives me enlargement of 1 3/4, 1.75. 10.5 divided by 6 is also 1.75. It looks perfect to me. But if you do the mathematics of the angles, if that's 108, that has to be 72 as the exterior angle, which makes that 72. If these are parallel lines, they have to be parallel lines, even though we don't have the little arrows on them, because we've got two right angles fixing the direction of that line, that line, that line, that line. So these are definitely parallel, but still the angles are not the same. All right, so they're not similar. It's very hard to spot. So that's grade 6. Okay. So these are similar, yeah, it's right there. We've done this in a previous video, and that was a really difficult question that I crashed on during the video, which is why I cut it short. Then I stayed at home and studied it and did it myself. It's a real mess there, but hopefully if you want to just scan and if you want to like stop the video and pause and have a little look and do some revision off that particular slide, that would be good for you. What's this? Oh, discerning whether they're similar or not. Okay, so we've done that. What's this? Try this one as an extension question. So these are similar. Find the missing sides, find the missing angles. Just to reiterate a very simple basic one. 12 divided by 6 is an enlargement scale factor 2, so 5 times 2 is 10. Now, I've probably said to many of you, don't bother copying this, just list the answers or write the answers on the diagrams if you can scan it and stick it into your books. So that's what that was about. And then this is Unit 6, reminders on probability. So I would have taken questions, but nobody jumped in. So what I want to do now is reduce that, so I can shut our vid and say goodbye, but not just yet.